Welcome to still chapter 3, the Keynesian theory. This is chapter 3, part 3, if I'm not mistaken. And this one will look at the other guys. So we saw the classical theory, and now we're going to do the Keynesian one. So obviously, this one is based on John Maynard Keynes' vision. And this man, he had his career during the Great Depression, which crippled the whole world in the 1930s. So this was a massive crisis. Yeah, just Google it. It's insane. Um, thing is, he stated that the absence of demand obstructed the way out of the depression. So you hopefully remember that the classical theory dealt with supply. These guys will look at demand. Very important distinction already. So households and companies don't always spend everything or all their money. They will obviously save or invest, right? Also, if the expectations look grim, they think, okay, I think the next coming weeks will be like terrible for the economy. I will not spend my money. I will save money right now, right? Um, Companies could be like, okay, I'm not going to buy that building as I planned because, well, yeah, difficult economic times. I will rather save my money, um, which is like a safer option. This is a vicious cycle because their actions right now will, in fact, make everything worse because they decide to stop investing, to stop consuming. They will stop economic activity and everything will come crashing down even harder, right? So they are actually part of the problem. So Keynes came up with a model. So he said, okay, demand is clearly an issue over here. We have to do something about that before everything gets worse. Now, the model we will be taking a look at will be a simple version. Once again, a closed economy without a government. We will talk about a country called Dalmasca. So this is a country that answers to our model's assumptions. It has no government and no trade going on with other countries. So here we have it. It's right here. Um, During the time I was making this PowerPoint, I played a certain game, and obviously there we have my inspiration. All right, it's way more fun to talk about Dalmasca than about Belgium, of course. So let's dive in now. Um, The citizens of Dalmasca, they work and earn money, like you and me, but what can they do with it? I think you realize that they can either buy goods and services or they can save their money. Um, it's pretty easy to get that if you earn more money, you will be consuming more. And consumption will be determined by national income. If you have a rich country and national income is high, this will allow consumers to buy more goods and services, stuff like that. So not too difficult, I think. We once again have to think about a certain law over here, and this time it's not about um, Jean-Baptiste Say or Say or I don't know, but it's about Engel. So Engel's law. This man stated that more income will increase our consumption, yes, but in the end we will spend less money on food, relatively speaking. I've made this case over here. This should make it clear. So on the left we have Arthur, and on the right we have Ali. And as you can see, um, Arthur, he spends 400 euros, or I don't know, the currency of Dalmasca, on food. He spends 200 euros on luxurious goods, and then he has 1.4k left. In the end, he has an income of 2,000 euros. Ellie, on the other hand, has an income of 4,000 euros. And as you can see, she earns double the amount of Arthur, but this doesn't mean she will eat double the amount of Arthur, right? Which would be like ridiculous. It doesn't mean that if you earn 10 times more money than someone else, that you will eat 10 times more than this person. Okay, You can buy more expensive food, but in the end, it won't be that much of a difference in this case. So as you can see, Arthur earns income 1 and spends 20% of his income on food. Ali earns income 2 and spends only 12.5% percent on food. So once again, relatively speaking, you know, there won't be that much of an increase in food. So the thing is, what will Ali do with this extra amount of money? That's something we will see. But think about Engel's law like this because it will return in future slides. So, but normally we know that more income means higher consumption. Thing is, there is a part over here that will act or operate independently of your income. This is called the autonomous consumption, and we will use the abbreviation CAU. The C comes from consumption, obviously, and A from autonomous. And no matter what a country earns, they will always spend something because they have to survive, they have to pay their bills, they have to pay for their food and their clothing, things like that. You will always spend money no matter what you earn. Here we have it. Even if they have no income, they will spend money. This can either be done by using your savings or borrowing money. Okay, here we have an example. Imagine that households consume 80% of their income and they spend 100 euros regardless of what their income is because of they still need food, right? Um, think about this. Companies also spend money. In this case, we use the number 50, and the total of planned spending will be called the effective demand, or ED. So this is a new concept, and this is something you plan to spend. So imagine you didn't receive your money just yet, but you already know you're going to spend money on certain things. That's about effective demand. And this is a ex ante concept, which means over here that before something happens, as you can see, the dotted line in the middle is the occurrence of the event. Something that is ex ante happens before the event takes place. I hope that is clear. It's not too important, but I'm just letting you know that effective demand is about planned investments. You're making a plan about spending things in the near future. So these plans might not be like accurate. That's important to know. More about this in a future slide. Okay, now everything we just saw on the previous slide, about 80% of the income will be spent, 50 from 100 will be spent regardless of the income, 50 for the companies. If we bring all of this together, we get the consumption function. So C, consumption, equals 0.8. That's the 80% of the income. Income is Y. That will be spent plus 100, the autonomous consumption. Here we have it once again. This could be billion euros, is spent regardless, not too important, but just know where the 100 came from. And if we use Excel, we can actually get the following information over here. So as you can see in the column called B, we have the income level of the country, and in the column called C, we have the equation. So if we put something different here in the equation where the Y stands, we get a different consumption level. So as you can see, if income is 0, we still will spend 100 euros, right? Because we still have to eat. This might be from savings, this might be from borrowed money. If we look at a very high income level, obviously consumption will also be very high. Okay? That's how this function works. Not too difficult, I think. Now, we arrive to a concept that is very, very important. It bears a a difficult name, namely the marginal propensity to consume, MPC. Okay, let's slow down and look what it means. This will measure the effect a change in income has on the consumption. So usually when income goes up, consumption consumption will go up, right? So you have this positive relationship over here, or relation rather. Um, so what will happen if our income goes up? What will happen with our consumption? This is what marginal propensity will measure. We will use the letter C, the small one, to abbreviate the marginal propensity to consume. And here is the formula. So MPC equals the small c equals the change in consumption divided by the change in income. This all sounds difficult perhaps, but you will see that in the exercises this is a very easy calculation and it's very easy to understand what it means. Example, here we have it. So um, imagine that you know that citizens of Dalmasca will spend 40 cents more for every additional euro they receive. So their income goes up with 1 and they spend 40 cents of it. So you will divide the consumption, which is the 40 cents, by the change in income, which is the euro, and then you will see that their small c, or their MPC, is all the same thing, will be 40%, which is fairly low. They will only spend 40% of every additional thing they get. So they will save a lot of money over here. Well, 60% will be saved in this case, okay? Then you have this video over here that you should watch. It's about the assignment. I'm not going to talk about it right now. It's something for to be discussed in class itself. Just watch the video and answer the questions in your textbook. Should be easy. If something is not clear, you can always message me, of course, right? Okay. Now, the consumption function can be drawn, of course. So the general equation, we already saw an example. So we have the small letter c, which is the marginal propensity to consume, and this will affect our income, y, plus the autonomous consumption. Here we have it. So these are the same numbers as before. And as you can see, we have this nice straight line going on that tells us that the more we earn, the more we will spend, right? So MPC was about consumption. This means that there is also another thing that deals with saving, namely the marginal propensity to save, MPS. So first we had MPC, now we have MPS. So if income equals, well, consumption plus savings, then I think you realize that with a small mathematical operation, you see that S will equal Y min C. I will remind you that C equaled 0.8 times Y plus 100. And if we bring all of this together, we get the following equation. So 0.20 multiplied with the income Y minus 100. This will be our savings equation. So you can see it has a direct relation with the consumption, of course, because the money that we will not be consuming will be saved. There we have it, the final product. And once again, we can use Excel and we can actually see that even if income is 0, we have a negative number over here. So minus 100. I think you realize that if income was 0, we were still spending 100 like euros. So this means we are losing 100 euros on our savings account, for example, over here. That's why it's negative. So the first few numbers are negative, and only starting from a income of 500, we are able to save money. So we are not saving money before that level. Only starting from actually 600, we're actually saving money. We are break even at an income of 500. That's how you can read this table. So once again, here we have the explanation. There we have it. Um, 0.2 will be the MPS. It's also visible in the equation. You always have to look at the number that is standing next to the y. So here we have 0.2y. 0.2 in this case will be our MPS or small s. It's all the same. There we have it once again with a nice red line to make it even easier to understand for you guys. So the MPS is the change in savings if income changes, while MPC was about a change in consumption if income changes. So you see, these two look alike. Here we have the formula, and there is one small addition. If you add C plus S, we get 1, because everything that you consume and everything that you save, well, together will be 1. That's a thing to remember. Okay, if we put everything together, so now we have a consumption function, we have the savings function, we have a column with our MPC and with our MPS, all separate. So this gives you a lot of interesting information. As you can see, C and S, they don't change. They're like always the same, but they will have an impact on everything else, right? If our income is very high, so 1000, you see that consumption will be 900 and savings will be 100. Okay, um, you can read everything over here, and I think you will understand how this works, right? Okay. Um, be aware that some people think that they just have to calculate 80% of this number 1000, and then you get 800. But over here we have 900. This is because you have to add the autonomous consumption as well, right? So be aware of that, please. Okay, so C plus S is 1 in every single case. The big C plus the big S also equals Y. So as you can see, we have equilibria all over the place. And eventually we can use our graphs over here to see or to check out the consumption and the savings function. And you see over here, only from like an income of 500, we can start to save money. We already saw that. Here we have the graphs. So, and that's everything about consumption and savings over there. Now we can advance to another party in Dalmasca. So you could take a break over here. I'm not going to stop, but you can take a break if you want to, because we just dealt with consumption and savings. Now we will look at what the companies will be doing with their investments. So take a break if you need it. If not, if you're a diehard uh, dude like me, you can just go on, or girl for that matter. But investments are also still something we have to consider. And the thing is, these are always in this model, always autonomous in Dalmasca, which means that no matter what happens, investments will always be, in this case, at 50. So the abbreviation that we will use is I from investments, and then we have the A from autonomous. This will change our formula for effective demand. So effective demand, may I remind you, is something we saw before. And right now we will recreate this. So the very first thing we saw was something with C in the first part of our model, and now we will be adding I. So the only thing that is changing is that we are including investments right now. So before we only had CY plus C autonomous, now we will add investments autonomous. And this will change our 100 over there with an extra 50 to change the formula to 0.80 times income plus 150. This is the new formula, the new and improved formula. This also means a new graph. There we have it. So investments are fixed, are always 50. That's why this red dotted line is just a straight horizontal one. And then we can look at the blue one is our new function or new equation, because this one is a bit higher than the previous one, the black one, because right now we are including the investments. So once again, the black one is the thing from before. Now we have the blue one. That's the important line that we have to be considerate of. Okay? All right. Now, there is something called the income effect. We know that effective demand, yeah, is all about demand. It's demand, right? Not too difficult to remember, I think. And Y is about national product, the amount of goods and services that can be bought with income. This will be our supply. Usually we use Y as supply. So once again, we will do the same thing over here. And this chapter is all about finding the equilibrium. So in here we will equalize ED and Y. Yeah, I know. Don't freak out. It's a massive table. I know. It's very big. Um, so what's new? As you can see, C and S returning. The big ones, also the small ones, the small C and S, are also returning. So that stayed the same. We also included some new income levels, as you can see. So nothing too difficult has changed. The only thing that's new, well, next to the new income levels, is this thing over here, like the ED column and the I column. Investments are always the same, and then we have ED over here. And as you can see, the ED equation is an improved version of the C one because we have added the investments. So the only difference between my second column and my 1, 2, 3, 4, 5, sixth column, I think I can count what 1, 2, 3, 4, 5. Yet my sixth column is the inclusion of the investments. Okay, so this is not difficult, right? It's easy. Just some numbers, right? But you have to know what each of them means, right? That's important. And now we can look at the important things. The income effect, we still haven't talked about that. Um, we still, I hope you still remember, that if income is zero, we will still be spending money. This was about Engel's law as well. He also stated that even though we have zero income, we will still be spending money. That's the thing over here. So you see that 100 will be the consumption, which means we cannot save. And ED will be 50 because we include investments. Nothing too difficult. If the income goes to 200, consumption will be 260 and I stays 50. This means that ED, will be 330. This can all be found in the table. This is how you should read it. And the income effect in this case is just, as you can see, we have more income, which will apparently increase consumption and will increase effective demand as a result. There is only an equilibrium, yes, at one level in our example, and you have to find it right now, but I will help you out. It's over here. How do I look for the equilibrium? You have to look at the income level, Y, and you have to take a look at ED. So don't take a look at C like before. Right now we have to look at ED equals Y, and we can see that 750 will be our equilibrium. It's marked with this red rectangle over here, very easy to spot. This is where our equilibrium shall be. Okay, so this point over here, the level of 750, will be our YE, so the income equilibrium. And now we're going to take a look at what happens if we have an income lower than YE. And lower, I mean a lower amount, so don't go like down in the table, I mean up in the table, because these levels of income are lower than 750. What will happen over there? Well, let's see. In this case, demand will exceed supply. Okay. Um, and this will create incentive for companies to expand their production. So they realize, okay, there is a lot of demand right now. We have to increase our production. As you can see here, all the levels below 750, and in each and every case, you can see that ED will be bigger than Y. Demand is bigger than income. Um, since demand is bigger than income, people will be saving, like, as you can see, like nothing. They can't save anything in these levels unless you're like over here. Here they can still save some money, but over here they cannot save. They're even borrowing money even, or using their savings in order to consume. Okay, so this is for levels below the equilibrium. Obviously, we'll also be taking a look at the levels above the equilibrium, and then we have the supply exceeding the demand, which creates a high stock and comes with costs. So imagine that you have a company. Think about Tom and his lemonade. Now his garage is full of lemonade. He needs more space, so he hires um, a building to put all of his lemonade. But this comes with a cost, of course, and this is bad news for companies. Here we have the levels with the high income, and as you can see, in each and every case, um, the income over here is higher than the effective demand. Okay, all right, almost there. The thing is, we've been using graphs and the table in Excel to find our equilibrium. Well, only the table in Excel actually. But we can also use good old algebra. So we know that we're looking for the y equals ED. So the first thing you will do is follow the red path over here. And you can see that ED equals C plus I. You already know the formula. And eventually, this will give you the equation 0.80y plus 150. Then you will start with the green path. This is the second thing you will do. And then you realize, okay, um, since this over here is my equation over here, so you will just be reusing this. And then over here, you have the saving side of the story. Eventually, you can find your a missing value y over there. It's simple mathematics. I don't think this is too important because I will always be asking you to do it in Excel. But it's nice to know. Then we have the graphs remaining, and obviously the spot where both of them will touch will be around 750 over here, and this is the optimal amount. The red line is 45 degrees, not too important, and the intersection will be our final result. Okay, well, not too important. It's nice to know. So just know that your red line over here, the standard line, is moving like at a 45-degree angle, and then this one is the thing you will draw in Excel, and then you find your equilibrium. Okay, that's chapter 3, part 3. This one was the biggest until now, I know. A very tough one, I think. A lot of things are important over here, but the main idea is that everything revolves around demand, the effective demand. That's Keynesian theory. It's all about demand, while the classical one was about supply. All right? I hope you did not lose all hope during this clip because it's quite a long one, just below 30 minutes. If you have any questions, send them through mail, Discord, I don't know, ask them in class, and I will see you in part 4. Okay? Until then.